Hi there, in this video we will solve the practice problems 2.6 and 2.7 from Fundamentals of Electrical Engineering 5th edition. So we will begin from practice problem 2.6, in which we have this circuit, and we have the 70 volts independent voltage source, the 10 ohm resistor, the dependent voltage source 2Vx, and a 5 ohm resistor, and we have to find the voltages across the 10 ohm resistor and the 5 ohm resistor, termed as Vx and V0 respectively. So to solve this problem, we will apply KVL on this circuit in the clockwise direction. Applying KVL, now you can see that the current is flowing in the clockwise direction and entering from the negative terminal and going towards the positive terminal. So there is an increase in potential, so we will write as 70. Then you can see that current is flowing from positive towards the negative for the 10 ohm resistor, so there is a drop in potential, so we will write minus Vx. Similarly, for the dependent voltage source, the current is flowing from positive towards the negative, so there is a drop in potential, so minus 2Vx. And for the 5 ohm resistor, the current is flowing from negative towards the positive, so there is an increase in potential, so we will write positive V0 and equals to 0. Now simplifying this equation, we will have 70 minus 3Vx plus V0 equals to 0, and we will name this equation as equation number 1. Now we will apply Ohm's law on the 10 ohm resistor and the 5 ohm resistor. When we will apply Ohm's law on the 10 ohm resistor, we can see that Vx, the voltage across the 10 ohm resistor, will be equals to 10I, and for V0, means the 5 ohm resistor, the voltage will be 5I. But as you can see that current is entering into the negative terminal of the resistor, so we will have a negative sign with the current. Now putting these values in the equation, we will have 70 minus 3 into 10I plus, minus 5I equals to 0. Now solving this equation, 70 minus 30I minus 5I equals to 0. 70 minus 35I equals to 0. We will take the minus 35 to the other side of the equation and then divide 70 from 35, when it will give us our current, that is 2 amperes. Now simply using Ohm's law on the 10 ohm resistor, Vx will be equal to 10 into 2. It will give us our voltage 20 volts, and for the 5 ohm resistor, the voltage V0 will be equal to minus 5 into 2. That will give us our voltage as minus 10 volts. Now for our other example problem 2.7, we have to find V0 and I0 in this given circuit. You can see that the whole circuit is in branch form, mean the whole circuit is in parallel, so we will apply KCL on the circuit. Applying KCL, now the source current, that is 9 amperes, will be equal to the divided currents, that is I0 plus I0 by 4, and plus the current flowing through the last branch of the 8 ohm resistor, and you can name it as I prime. Let's say we name it as I prime. Now again we will write the equation 9 equals to I0 plus I0 by 4, and we will apply Ohm's law on the 8 ohm resistor. Then I prime will be equal to V0 over 8. Now we will take the LCM of the terms on the right. 8 I0 plus 2I0 plus V0, and multiplying this 8 on the other side of the equation will give us 72 equal to 10 I0 plus V0. Now as you can see that the whole circuit is in parallel form, so in parallel the voltages across each branch is same. Voltages are same. So the V naught voltage that we have to calculate in the last branch will be equal to V, means the whole circuit will have the voltage V. So we can apply Ohm's law on that 2 ohm resistor as V equals to 2 into I naught to I naught. Now we will put this value of V in the equation because the voltages are same in the whole circuit. You can see that V naught equals to V. So we will put the 2 I naught. So it will give us 72 equals to 12 I naught. Dividing 12 on the other side of the equation will give us our I naught, that is 6 amperes. Now we will use this I naught to calculate the current in the last branch, that is I prime, and then we'll apply Ohm's law on that branch. So calculating the I prime, 9, and taking the I naught on the other side of the equation will make it minus I naught, means minus 6, and minus 6 by 4 equals I prime. Solving this whole equation will give us our I prime, that is 1.5 amperes. Now simply applying Ohm's law on the 8 ohm resistor, we will have our voltage V naught equals to 1.5 multiplied by 8. It will give us our voltage, that will be 12 volts. That is all for this video. I will see you in the next one.